The purpose of this tutorial video is to introduce you to the signed rank test and to learn how to calculate that test statistic and p-value using StatCrunch. The signed rank test is a non-parametric test which can be applied to interval ratio data that's not normally distributed or ordinal data. So in the second example that was given in the notes, we had hair growth drugs that we were studying on pairs of men. So for instance, if we consider this first row of the StatCrunch dataset, we'll see that the man who received drug A gave a response of 1, which corresponded to some hair growth, while the man that was given drug B gave a response of 2, which corresponded to moderate growth. Now, the purpose of the test is to determine if there's a difference in the two drugs. So in order to do that, the first thing that we have to do is we really need to calculate how different the two drugs are. Because remember, when dependent samples are taken, all the inference that's done will be conducted on the sample of differences. So what you can see is, if we consider taking drug A minus drug B for the first observation, that would give us a difference of -1. Now, to get the -1 there, I literally typed it in. So for a large sample, you don't want to go through and type in the value of your difference every time. So what we can do instead is we can let StatCrunch calculate those differences for us. So if you go under the Data menu, an option that you have is that you can compute an expression. So you'll notice that there are several different functions that StatCrunch gives for computation. And what we'd like to do is we'd like to do the difference. So I'm going to select y minus x. Now, in order to set the expression that we'd like StatCrunch to compute, I need to choose my y column as drug A, my x column as drug B, and then you're going to click Set Expression, and you'll see that what pops up in the expression box at the top of your screen now says drug A minus drug B. So instead of me individually going through the 30 pairs of men that were sampled and calculating their differences individually, StatCrunch will do that calculation for me. So if we come down and click Compute, you'll see that a column gets added to your worksheet, and that column is called drug A minus drug B, and you'll notice that those first several differences that I calculated agree with the differences that StatCrunch calculated. Now that we have our differences collected, we can proceed with looking at the signed rank test. Now, in this case, we would never have considered a t-test for this data because the variable that was recorded was ordinal in nature. So we had 3 levels. 0 corresponded to no growth, 1 to some growth, and 2 to moderate growth. So the 0, 1, and 2 are completely arbitrary assignments, so it makes no sense to talk about the average hair growth. Instead, we'd like to compare the median. So much like the Mann-Whitney test, if we go to the Stat menu and to non-parametric, you'll see that the second test that's given is the Wilcoxon signed rank test, which is the test that we would apply to this data since it's dependent. So if we select this test, we have to select the column that we'd like to compare. In our case, the column that we're interested in is the column containing our differences, so drug A minus drug B. If we click Next, we can select what type of alternative hypothesis we'd like to test. And in our case, we do want to test a not equal to because we were trying to determine if there was any difference in the two drugs. If we click Calculate, you'll see the familiar output that you're probably getting used to by now. So we have that we tested the median of our variable, so our median difference. You notice that your test statistic was 20, and your p-value was 0.0004. Now, the p-value of 0.0004 is smaller than any significance level that we would ever use. Therefore, that leads us to the decision to reject our null hypothesis. So our conclusion will state that there is evidence of a difference in the median hair regrowth of the two drugs. So in this case, if you've told me that the medians aren't the same, that implies that one has to be larger than the other. Now, in the case of the t-test, we would typically go back and we would calculate a confidence interval to determine how different those two means were. You can go back and calculate confidence intervals in the nonparametric test. However, they start to lose some of their meaning, especially when you're dealing with ordinal data. So instead, to make the decision as to which drug promoted more hair growth, we're going to come over and look at the estimated median. So you'll notice that this median estimate that's given is negative 0.5. So if you think about the median being negative, that means that the difference in the median growth for drug A and the median growth for drug B was negative. The only way that that can occur is if drug B, our second sample, has a higher median than drug A, our first sample. So our final conclusion is not only that there's a difference in the median hair growth for the two variables, but we can also conclude that the median growth with drug B is actually greater than the median growth with drug A. If you have any questions on the signed rank material, please let me know. The hardest part about this test is that inside your worksheet, you are going to have to make StatCrunch compute your differences for you. So again, that was under your data menu and compute expression.